This lesson is a continuation of Chapter 1. We are covering 1.2, Permutations. A permutation is an arrangement of objects where the order makes a difference. So for instance, if I asked you a very simple, how many permutations of the letters A, B, C? If the order of the letters does make a difference, then I need to provide all possible ways for that to happen. So obviously A, B, C, or I can just switch around the B and the C. Then I have my options to start with B and my options to start with C. There are 6 total permutations. Now again, it depends on the question being asked. If I only want to know how many permutations, then I can just use the multiplication rule and say there are 3 options for my first letter. I've used a letter, so there are 2 options for my second letter. And I've used 2 letters, so there's only 1 left over for my third letter. So that's a total of 6 permutations. That's the same product rule, multiplication rule that we just learned in section 1.1. Now obviously for just 3 items, it's pretty straightforward, but let's talk about a generalization of that. If I had n letters, so 100, 1,000, a million, etc., how many distinct permutations exist? Well, if I'm using all n letters, then there are n options for the first, 1 less than that for the second, 2 less than that because this is actually n minus 1 minus 1 because it's 1 less than what I had here. This is n minus 2 minus 1 because it's 1 less than I had here, etc., etc., all the way down to when I have 1 last option. We call that factorial, so n factorial. That's what helps us to be able to determine all of the permutations. Again, that's using every single letter. And then I've given you the formal definition as well, so it's very important that you're able to read and understand math lingo. This is saying for an integer, n is greater than or equal to 0. N factorial, denoted n with the exclamation point, is defined as 0 factorial is equal to 1, and that's very important because we need to know that in order to move forward. And that n factorial is n times n minus 1 times n minus 2 all the way down to 3, 2, 1, etc. for any n that is greater than or equal to 1. So let's take a look at an example that should be pretty familiar to us, this same concept we talked about before, and then we'll talk about how this relates to permutations. So say I have a pool of 10 candidates and 3 are chosen to be president, vice president, and secretary. How many such linear arrangements are possible? So this I don't need that permutation definition for because I'm not using all 10 candidates. If I said how many linear arrangements are possible for all 10 candidates, then I would take 10 factorial and find my solution. What I want to point out to you is that while I can solve this the same way I did in section 1.1, which is saying there are 10 candidates for president. Once I've chosen a president, there are 9 left for vice president. Once I've chosen those 2, there are 8 left for secretary, which is 720. Note that it's equivalent to essentially 10 times 9 times 8 all the way down to 1, which is 10 factorial, which now all of a sudden we see how permutations might come into this. And then I divided it by 7, 6, 5, 4, 3, 2, 1 because what would happen here is all of these would cancel and I get my same answer of 720. Before we begin to formalize our definition of permutations or the formula that we might use, let's look at another example that's very similar to what we just talked about. Suppose I have blocks numbered 1 through n that are in a barrel. We pull out k of those blocks. So I'm just using k and n instead of actual numbers and placing them in a line. How many different arrangements of k blocks might we see? So before we actually look at solving that, it's really the same as what we just talked about. Before I had 10 candidates. I had 3 arrangements that were possible. 3 positions that were possible. So I had 10 times 9 times 8. So now if I'm looking at the same concept, but instead of 10, I'm replacing it with n, and instead of 3, I'm replacing it with k, well, what's going to be different? I'm still going to start with n possibilities here. This is going to be n minus 1, n minus 2, etc., 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 down to what? Well, down to n minus k plus 1. So what does that mean? Think about it in terms of my 10, 3. 10 minus 3 was 7, but I didn't end with the number 7. I ended with the number 8. That's where that plus 1 comes in. So 10, 9, 8. This is how many possibilities there might be. So this is going to bring us to our definition of permutations. Our definition of permutations states that if there are n distinct objects, the number of permutations of size k, with obviously k being a value between 1 and n, for the n objects is p n comma k. So again, this is just notation that you should become familiar with, which this is sort of the development of it. This is saying, okay, we're going to have n and then n minus 1, etc., all the way down to n minus k plus 1. Now, if I wanted to rearrange that a little bit, essentially what I did was I took this all the way down to the permutation on the top, which was the factorial on the top, all the way down to 1, but I'm actually dividing it by something, which is why all of those other things are canceling out, making it stop right here. Now this is an important concept because that's what allows us to get to this point. And this is the definition for a permutation. So p n comma k will get us to n factorial over n minus k factorial. But again, it's important to understand where the n minus k came from, which is to say, starting at n minus k, I want to cancel those with what would be left on the top so that I only end where I want to end, which is n minus k plus 1. So let's look at an example where we can use this new fantastic formula that you should commit to memory immediately. It says, how many ways can the letters A, B, C, D, and E be arranged in groups of 3? So again, dealing with this, I've got 5 letters, and I'm putting them in groups of 3. So 5 would be n, because that's the number of objects that I have, and I want to arrange them in groups of 3, so k is 3. So I'm going to denote that p 5 comma 3. Sorry, I crossed over it. P 5 comma 3 to denote that I've got 5 objects in groups of 3. And then I'm going to use my formula that says take n factorial over n minus k quantity factorial. So 5 factorial, I can use my calculator to determine, is 120, or do it in my head. 5 minus 3 is 2. 2 factorial is 2 times 1, which is 2. I divide those two, and I find out that there are 60 options. So again, why did we divide by 2? Because that formula is taking into account that both of these guys are the same arrangement, because I'm only worried about the first 3, A, B, C, and I don't care if E, D, and D, E, which order they're in, because I'm not paying attention to them anyway. So it will be important for us to know how to use our calculator to calculate some of these things for us. Now keep in mind that sometimes I will only ask for the setup of the problem because the numbers are very big, but obviously in this case the number is not very big. So in order to find the permutation of 5 items arranged in groups of 3, I'm going to go to Math, and then I'm going to just use my arrow button to go over to Probability, and notice that number 2 is NPR, and so again NPR same as NPK. In this case it's 5, choose 3, and then enter, and it will calculate that product for me. If you'll recall, I previously defined how to determine a permutation, and I defined that 0 factorial must be 1, so that if n was 0, then we would use this definition. If n was greater than 0, meaning 1 to infinity, basically, then we would find n factorial. So I sort of glossed over this and didn't tell you why, but let's take a look. Let's say I'm looking at finding permutation of n items in n ways. So that could be 3 items in 3 ways, which would mean the numerator would be 3, 2, 1. The denominator would be 3 minus 3, which is 0, and 0 factorial needs to not be 0, because otherwise I would end up with 6 over 0, and we all know that's not okay. So 0 factorial must be 1 for my answer to work out as 6. So this is a specific example using n of 3, but here is the general example that n choose n would be n factorial over n minus n factorial, which of course is 0, which is why we end up at n factorial. Let's take a look at going to the next level with this, which is permutations with repetition. So with repetition, obviously, is going to happen quite often, and what I mean by with repetition means that I've got a repeated value. So for instance, in the word oboe, I've got 2 O's, and basically I capitalized 1 just so you can see what all of the different combinations were, but essentially what I'm looking at is the fact that these two guys are the same, because the only thing different is the placement of the capital versus the lowercase o, and I really didn't have to capitalize. I only did that to show that they were different. So really we're looking at 12 unique options, which would be the 12 columns that I've shown here. Each of the bottom row is really just a repetition of what is in the top row. So typically what I would do if I had 4 values and I'm using all of the letters is I would just find the permutation 4, 4, which means 4 values. I'm permutating each of them. So I'm using all 4 values, which would of course be 4 factorial, which would be 24. In this case, because the numbers are the same, we also have to divide by 2 factorial. Because we have 2 numbers that are the same, we divide by 2 factorial. So notice it's the exact same as I had here, but I'm taking it to the next level by dividing by 2 factorial, which then gives me 12, which is what I wanted. So our formula for this essentially says that if I have n objects, that I'm using all of the objects. So again, it would really be p n choose n. But in addition to that, I have some indistinguishable objects, like the 2 O's that I talked about before. In addition to me dividing by n minus n factorial, which is 0 factorial, which I don't need to list, I would divide by whatever the value is of my set. So if I had 2 O's, that would be 2 factorial. If I had 5 F's, then it would be 5 factorial, because those are indistinguishable objects. So again, we can use our calculators for this, and we're going to do that real quick before we try any more practice together. So what I know is I can either go to the same steps that I did before, which was math, arrow to probability, choose NPR, and in this case I had 4 options and I'm using all 4 of them, but because I'm dealing with O and another O, I'm going to divide it by 2 factorial. So where do I find factorial? Well, I'm going to go ahead and write my 2, then I'm going to go back to math, and I'm going to arrow over to the same place, and notice it's just right here at number 4. So I can do that to get the 12 that I had found before, or because I know the formula for permutations with repetition, I can also just type it all in myself, of course, which is 4 math probability factorial, and then divided by, and then 0 factorial I'm not even going to bother with, and then 2 math probability factorial. Either way, I get 12, so whether you choose P for permutation 4, choose 4, or if you choose 4 factorial, that is completely up to you. Here's your last questions. And just as before, I always like to end with questions that will first just test your knowledge of the basic concept and then challenge you. So they will get harder. Question 1 and 2A you should be able to do without breaking a sweat. B and C will make you think a little bit. When you're ready, press play to see how you did. So starting with my banana question, remember we're looking at permutations, and this is specifically with repetition. That's what this practice is all about. So in how many ways can I arrange the letters in the word banana? Well, by my count, there are 6 letters in the word banana, so my numerator is 6 factorial. Because we're dealing with repetition, there will be values in my denominator, and that will be anything that I have that's repeated. So here I've got an A, so I have one set of 3 things that are repeats, so I'm going to divide by 3 factorial. In addition, I've got 2 n's, so that's 2 factorial. Do I have to worry about the b? Well, the b is a singleton, and we don't care about those, so that's going to be my final answer. 6 factorial over 3 factorial, 2 factorial, which turns into 60. Question 2, how many arrangements are there in the words, or are there in the letters in sociological? So again, first thing I would do is count how many total letters I have, which is 12 total letters. So 12 factorial is my numerator. This one obviously a little bit harder than question 1 just because we have more repeats, but let's take a look. I've got O, 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 so that's 3 factorial. I have C, C, that's 2 factorial. I have I, which it kind of looks covered up, but there's one in there, and another I, so that's 2 factorial. And I have an L and an L, so that's another 2 factorial. And then I look at what's left over to make sure I didn't miss any. I've got an S, I've got a G, and I've got an A. So S, G, A are my singletons. I don't care about those, so that's my final answer. And again, you could go ahead and find that as a raw value as well. So that takes care of the 2 sort of straightforward ones, and now we need to look at the ones that are trickier. And for B, as you can see, I've given you a little bit of a hint already, but maybe that wasn't enough for you to be able to figure this out. Really what I want to do is think about the fact that I have a letter that I'm taking A and G and basically fusing them together. So I'm either fusing them as AG. Wow, my handwriting was atrocious. Let's try that again. I'm either fusing them as AG or I'm fusing them together as GA. Now remember that OR tells me I'm going to add those 2 values together. So if AG is together as one letter, how many letters do I have? Well, I started with 12, but now I'm taking AG and basically saying that's one letter. I'm going to permutate that together because I've fused them together. So I have 11 factorial letters. Well, 11 letters, which is 11 factorial. Did me fusing A and G together affect any of the repeats? Well, no, because A and G are 2 of my singletons. So my denominator is exactly what it was before. And then I'm going to do the same thing for GA, and as I'm sure you probably guessed, that means there are 11 letters, so I'm going to permutate those with the same denominator as before. So that's going to be my solution for B. Or I could have just said 2 times 11 factorial, 3 factorial, 2 factorial, 2 factorial, 2 factorial. So now let's take a look at the hardest question. And I got to make room because all of this is going to be words down here when I uncover the answer. But let me try to explain it to you before I uncover the answer. What I want to do is I want to take, just like I did for AG and for GA, I want to take all of the vowels and I want to stick them all together. So how many vowels do I have? 1, 2, 3, 4, 5, 6 vowels. So I have 6 vowels, 6 consonants. What I'm going to do is I'm going to take all of these and I'm going to make that one letter. because they're all going to be together. So what do I have? I have 7 total letters, the 6 consonants and my 1 massive vowel letter. So 6 objects to permutate. 7 factorial. What do I have that are repeats? Well, here's where you have to think about the fact that I'm not going to worry about the vowels yet because that's just 1 letter. So when I talk about repeats, I'm only talking about repeating consonants. So what do I have for repeated consonants? I've got my C's, which are yellow, and I've got my L's, which are blue, and the other 2 seem to be vowels. So I'm going to do 2 factorial, 2 factorial. And in fact, I'm just going to go ahead and use those colors again so we remember where they came from. 2 factorial and 2 factorial. So far so good, but I'm not done because I've sort of glossed over the fact that this 1 letter does have some repetition in it and can be permutated in a bunch of different ways. So now I'm talking specifically about my vowel. How many ways can I arrange that? Well, there are 6 letters in my 1 letter of the vowel. And we talked before about the fact that there were 3 factorial for the O's and 2 factorial for the I's. So that is going to be my final solution because it's letters specifically for vowels. So I'm going to erase my work so I can show you the real written solution that I have written down, which is not as colorful, but is exactly the same solution that I just came up with. So again, C was very difficult. Good job if you got it right.